Hello, my name is Jim Olson, and this is a introductory video on number theory. In this video, I'm going to be talking about properties. The first handout I have tonight is a two-sided handout. It's a foldable, and it is math properties. And when you fold this and look at it, we have the property name here. For example, the first one is the associative property of addition. When you open this up, first of all, it tells what the in this case, associative property of addition means. It means you can change the grouping in addition. Then the property is stated. On the back, there are some examples of the property. In this case, it's the associative property of addition. So on this foldable, we have the commutative properties, the associative properties, identity properties, inverses properties, the distributive property of multiplication over addition, and the zero property of multiplication. You might note that there's a zero property of multiplication, but there's no real corresponding property in addition. We do have the additive identity property, which has to do with zero. And I will put the link to this foldable in the notes down at the bottom. Okay, now I'd like to go to chapter 1 in our textbook, and I will put the link down in the notes. In section 1.1 here, we have the definition of integers and the notation here. It's this Z with kind of a double bar through it. This is the positive and negative whole numbers. The natural numbers are the counting numbers, and we use this symbol here, which is an N with a double bar through it. These are the counting numbers. Here in section 1.1, we also have the commutative properties, associative properties, very similar to our foldable. Here are the inverse properties. The properties are quite important in the Common Core state standards. So let me show you how you can get to the Common Core state standards. Of course, you can Google for the Common Core state standards. I have them linked on my homepage here. I have the Common Core standards information, links, and resources. And down here in the actual CCSS, Common Core State Standards, I have a link here, and this is a 93-page PDF. And at the back, we have the properties. Here on page 90 of the Common Core State Standards of Mathematics, we have the properties here of addition and multiplication, and they also have the other properties here. For example, the addition property of equality. The addition property of equality states that if A equals B, then A plus C equals B plus C. This means you can add a number to both sides of the equation. Similarly, the division property of equality. If A equals B and C is not 0, then A divided by C equals B divided by C. This says that we can divide both sides by a number as long as we're not dividing by 0. And the substitution property is here as well. And these are on our foldable. Now I'd like to do some example properties. In questions 6 through 8, we're supposed to state the property, which is the justification. If it's arithmetic, like 2 plus 3 equals 5, just state arithmetic. So let's look at number 6. Number 6 says that 5 times 7 times 4 equals 5 times 4 times 7. What we need to do is analyze this and see what has changed. 7 times 4 has been changed to 4 times 7. This is the commutative property of multiplication. Notice that commutative has a root word of commute, which means to move, whereas the associative property has the root word associate, which means to group. So this one is the commutative property of multiplication. Now let's look at number 7, and let's see what has been replaced. What has been replaced is 4x plus negative 4x has been replaced with 0. This is the additive inverse property. Notice that there is some multiplication in the statement, but we're not changing anything about the multiplication. So this is not a multiplication property. Now let's take a look at this argument here, which are the steps for solving an equation. The first thing we're doing is we're subtracting 3 from both sides of the equation. This is the property of equality. We have the subtraction property of equality. Now, in the next line, 3 minus 3 is being replaced by 0, and negative 7 minus 3 is being replaced by negative 10. This is arithmetic. Now, on the left-hand side, 3 minus 3, we could argue that that's additive inverse, but let's just put arithmetic. In the next line, we have 5x plus 0 is equal to 5x. What property is this? This is the additive identity property, or if you wish, you could call it the identity property of addition. In the next line, we're dividing both sides by 5. What property is this? Division property of equality. And finally, we do some more arithmetic. So the reason for line E here is arithmetic. Okay, I'm going to return to our textbook, and we're going to take a look here at the well-ordering principle. So we're going to be looking at the integers, but it's going to be the positive integers. So this could be stated as a property of the natural numbers, but the way our textbook author has written it, it's this property of the positive integers. The well-ordering principle states that a least element exists in any non-empty set of positive integers. Now, this sounds almost trivial, but it is an important property. So let's take a look at some examples. I'm going to see if I can get my pen to work here on the computer. This set, which is a finite set, which is 6, 20, and 21, also has the well-ordering principle because it has a least element. The least element is 6. Now let's take a look at this set. And I need to explain the set builder notation if you don't remember how this works from college algebra. This is the set of all x such that x is an element of the real numbers and x is greater than 5. The E symbol means belongs to or is an element of. The vertical line in this situation is a divider between the x and the description of x. The first thing we have in the set x is the type of thing that we have, and after the vertical bar, we have the description. On a number line, this would be an open circle on 5 and going to the right. And the question is, does this set have a least element? You might think about that. Is there a single least element? And the answer is no. If you think the least element is 5.1, you can get smaller than that, 5.01, and you can get smaller than that. This set does not have the well-ordering principle. Now let's look at our last two. examples. Number 9 is the set 7, 9, 11, 13, 15, and so on. This is an infinite set. It looks like it's the odd numbers 7 or greater. And this set does have the well-ordering principle. Our next set is the set of all x such that x is even. X is an element of the integers, and x is greater than 13. So we have even integers. Of course, that would be -4, -2, 0, 2, 4, 6, 8, 10. But in addition, x has to be greater than 13. The question is this well ordered? Yes, it is well ordered. It does have a least element. The least element in set number 10 is 14, and the least element in set given for exercise number 9 is 7. Have a great day.